Hi everyone, I wanted to record a video. There's a question on the homework that a lot of people are struggling with, and so I wanted to record a video to explain a little bit more about it so that you know how to complete the question, okay? The question reads, a 100 watt light bulb radiates energy at a rate of 100 joules per second. If all of the light emitted has a wavelength of 525 nanometers, how many photons are emitted per second? And it also tells us that 1 watt is equal to 1 joule per second. Now, from your equation sheet here, see if you can see that. Try to get the glare off, okay? We can find out that the energy of a photon is hc over lambda, okay? Well, lambda is our wavelength. We use a lowercase lambda to equal our wavelength. And so our wavelength is 525 nanometers. Some of you guys may have gotten a similar problem, not the exact problem. Yours may be a little bit different, okay? So we know this, and then we also know that the energy is equal to hc divided by lambda. Now, we haven't talked about well, you may know from the book what hc is, but one other thing we need to know is that it's a 100 watt light bulb, okay? So that means that it also tells us that 1 watt is 1 joule per second, okay? So we can say that we have 100 joules per second of energy moving through this light bulb, okay? So what we're going to do is we're going to calculate the energy of all of these photons. Then we're going to divide 100 joules per second by our energy here, okay? So H is Planck's constant. Let me show it to you on your equation sheet here. Planck's constant, H. And then C is the speed of light in a vacuum. Okay, and that information is there, okay? So we're gonna write that down. So we have Planck's constant, 6.626. I just do that, times 10 to the negative 34s, and our unit is joules per second. So the tricky part is knowing that we're gonna have to take 100 and divide it by our answer here. That may be what some of you guys, what is throwing off some of you guys. So then our speed of light, 2.9979. Sometimes you can do just 3 times 10 to the 8th, but if we want to keep our significant figures to make sure we have it exactly right. Okay, and that's meters per second. Ooh, look, guys, we gotta watch our units. Our lambda wavelength is given in nanometers, but here we have meters, okay? So we need to convert these nanometers into meters. Okay, and from the bottom of our equation sheet, we can see here that nano is times 10 to the 9th. Or I could just write it like this. Okay. So 1 nanometer is 10 to the negative 9th meters, so we can just write this, 525 times 10 to the negative 9th meters. Okay, I'm running off my page, but you guys can see that. Okay. Okay, so that's going to cancel out our meters, okay? And then we have joules, and we have seconds in the denominator and seconds in the denominator here, okay? So my answer there is going to be it's going to be joules per second squared, okay? So I'm going to plug this in my calculator. When I do that, let me do that real quick. Trusty calculator. Okay, so I'm gonna get 3.78, and I'm gonna keep all my digits there, okay, times, so I have minus 34, 10 to the 8th, times 10 to the negative 19th. Okay, so then when I take, so then what I'm going to do is, so my units are joules per square seconds. Okay, so then I'm going to take, to get, and so this is total, so this is all photons. Okay, so if I need to know our number of photons, I'm going to take 100 joules per second and divide it by, okay, this 3.78 times 10 to the negative 19th. Make sure I did my exponents right. Sometimes I make mistakes on my exponents. I do my very best to not. Let's see. I get 2.64 when I use all my digits times 10 to the 20th. Okay. And so, and my units here are joules per square seconds. Okay. So my joules are going to cancel out. I have seconds going up to the top, and that gives me inverse seconds, okay, which is weird. But what that means is that that actually is photons per second. Okay, so photons per second. So I hope this helps. This is how you would do a problem like this. Watch your units. They're really complex here, okay? So watch your units, but there's your answer right there. Good luck.